This illustration deals with supplying a panel board through a transformer in accordance with 408.36b exception. Now notice the primary, the conductors and the overcurrent device to the primary of that transformer are basically designed, if it's 1,000 volts or less primary, in accordance with table 450.3b, which we have a very excellent chapter on transformers. And I believe it's chapter 20 of the NEC, or I shouldn't say the NEC, but Stallcup's electrical design book that deals with Article 450. But what we're trying to point out here, let's look at the Quick Calc 1. And this is basically what trained electricians would use in the field. If you had a 480 volt primary, as you see in the illustration, and let's just say you had a 240 volt secondary, divide the primary of 480 volt by the secondary voltage 240, and that is a 2-to-1 ratio, and we use it as a divider on the secondary side of that transformer. So on the secondary side of the transformer, notice we have a 100 amp panel with 100 amp conductors and a 100 amp main. So you take the, say the 100 amp main or the 100 amp conductors, divide by 2, and that's 50 amps. And the overcurrent device on the primary would be rated at 50 amps for a ratio-to-ratio protective scheme. You say, well, what if I take 2 and multiply times 50 on the primary? Now you derive the 100 amps on the secondary as illustrated in the Quick Calc 2. So on the primary, the 2 is a multiplier, but on the secondary side of the transformer, it's a divider. And that's what electricians, they don't get confused as easy using the primary voltage in relationship to the secondary voltage and dividing, if the primary is a higher voltage, by the lower voltage. And for example, if it was 480 volt primary and 208 volt secondary, then you would take 208 volt into 480, and that'd come up to about 2.33 as your multiplier or divider. Now we show that in the boxed in information at the top right-hand side of the illustration. We show step 1 that we're applying 240.4F in Article 240 because we're dealing with overcurrent protection. If you wanted to use the formula, it'd be 240 divided by 480 times 100. That would give you 50 amps. Electricians say, I don't remember that. But I do remember how to take 480 primary, divide by the 240 volt secondary, and then I'm going to derive the same thing. If I take the 100 amp conductor rating and the 100 amp overcurrent device rating, divide that by 2, I come up with 50, just as I did in the step 1. So what we're doing is taking primary to secondary voltage ratio and determining the value rating of the overcurrent device in the panel board, as well as the overcurrent device in the service equipment. And then we'll get into these requirements in more detail as we go through this presentation, based upon which chapter deals with what subject. So figure 7-18 deals with supplying a panel board through a transformer in accordance with NEC 408.36B as in boy exception.